Thank you for attending to this GBI webinar. This is hosted by GM International. Of course, the company is giving for free this session. We would like to remember you that you can attend to this webinar. You cannot talk, you can make questions. There is a Q&A button on your bar. So you can, of course, make your question. We try to answer during this session, unless maybe critical or maybe too complicated or maybe not relevant information. Maybe we cannot, we have not the time for giving you all details. Yeah, and this webinar is recorded, so you can later you can of course, review it. You can send to your colleagues. We have, of course, a YouTube channel where this will be stored, and where also, of course, you can see all the other we organized during the past years. More topics, of course, and so on. Okay, so we can go ahead on this webinar. Don't know if we must. Okay, let me check because we have to set better my computer. Okay, perfect. Today with me there is Massimo Calerio. Hope you can see. Can you see? Can you confirm, Maurizio? I'm sharing the presentation.
Yes. Yeah, I confirm we can see. Yeah.
Okay, perfect.
So I can start.
Yeah, please, Maurizio.
Yeah. So thank you, Andrea. I see that there are already present a lot of participants. So probably we can start slowly. And thank you to all. Andrea will be the main speaker. I would like just to introduce ourselves. So Andrea, that is our global account manager. Andrea is in GMI from a lot of years, and he has a lot of experience in the automation market. He mainly followed the contractors, Mac, and all the projects and all over the world. While for myself, unfortunately, I have a lot of experience, so it means that I'm not so young. But okay, I follow the automation market and in particularly the AX area from a lot of years. I've experience in the field, so in the instrumentation, as well as in the distributed control system and so on. Now I follow the European market, and it's not simple, but it's a challenge. So we will see. Okay, so now just a few words about the company, what we are, what we do. So our products are dedicated for the automation packages usually. And so the DCS company for the ESD, the fire gas system, the burning monitoring system, and so PLC, SCADA, all these kind of systems, and in a lot of different sectors. Obviously, oil and gas is the first one, but also petrochemical, pharmaceutical, and all other chemicals markets. Mining is very important in some countries, and also food. We have more than 40 years of experience. The Elcon Instruments company was founded in 1993, a lot of years ago. Then we have GMI started with the family Landrini and so on. We have all the internal production, so 100% of our components are produced, designed, engineered in our factories close to Milan, Monza, where there is the Formula 1 GP. So it's a nice place to see, to visit. We are also open for some visits of the customers to let them see our production. And obviously we are a global player, so we are present in the 5 continents. So Where we are, we have 9 GMI offices in the world. So we are present in the US, in Singapore, China, Japan. And we have a lot of distributors in Europe and also in the other part of the world, just to cover all the countries possible. More or less, we are 200 people as a total staff, divided in our headquarters and in the local offices. We do obviously the safety courses with the help of our trainer Tino van de Capelle or directly. And obviously, we have thousands of installations in everywhere, all the continents. Thank you, Andrea. So we are ready for a safe world. So we put safety, seal, and so on in front of our product. So we do traceability of the products. So we know everything of our components, where they are coming. We do the full testing of 100% of production. So it's not simple to find a producer that do this. Usually testing is done on a percentage, 10%, 20% of the product. For us, it's important to do this on the complete production. We also have all automated, so the manufacturing with few people, less personnel and a lot of machines. We give the 5 years warranty for all of our products. Also in this case, this is a plus respect to our competitors. And obviously, we guarantee the availability for 10 years of the products. Certification, obviously, to be present in this kind of market, we need to have a lot of certification to cover the AX area, obviously, not only. We also have the SIF certificate, TÜV, naval, marine, so a lot of certification. Obviously, it's difficult to say we have 100% of the certification. We are more or less close, but we are also open to verify, to see together with our customer if there is any particular need.
It's coming.
Yeah, this is our production. So most of you probably already know. We produce barriers, that is our main market, but also safety relay. Safety relay, we have a very wide product range of these, divided with the product with more features, less features, and so on, but Andrea will explain you better later on. Isolators, so where it's not necessary to have the intrinsically safe, but is only necessary to have the galvanic isolation. Then we have also power supplies, not the standard or the simple one, but the first of all, SIL 3 certified. And then there are also ATEX certified for installation in zone 2, hot swap and hot standby, redundant, and so with a lot of features. We also have a multiplexer for digital and temperature system, so they can be placed in a field, and then with a standard double cable can be sent all the signal to the DCS or control room. We have the termination board, the standard one, or the dedicated to the DCS supplier. So for the biggest name, we already have a termination board dedicated, so they can arrive with the standard flat cable and the connector directly on our board. Then we have a hard multiplexer, surge protectors, and also now we have started the launch just a couple of weeks ago with the new series X1. Obviously, we do also courses and services for the seal and safety application. These are more or less in only one page all our customers, starting from the system vendors, so all the MAC our main automation contractors, DAPC, the engineering company, OEM, so we have obviously a lot of OEM using our products, and finally the end users. And this is more or less what I wanted to say about GM. And I finished the introduction, so I leave you to Andrea for the topic of today.
Thank you, Maurizio. So we can start with the safety relays part, which is a very important part. I would say that this is the first, say, is an example of a loop where you have, of course, you start from the sensor, you go to the system, and you go finally to the final element, maybe, of course, an actuator and the valve. This is, let's say, the PFD or PFH indicates the possibility that a device is able to carry out the safety function. And when you, of course, when you put something in this loop, of course, yeah, we put our, so let me highlight with a pointer so you can see this is, of course, a barrier. This is the system. This is basically a safety relay that is driving a load or an intrinsically safe barrier. But anyhow, each of these devices, of course, is that is applied in the loop has to be SIL certified and is contributing to the SIL certification. So, and all these systems, of course, have to be safe, and this is the mandatory requirement for all loops. Also, the power supply that is included in this loop, because it's powering the device, have to be included in this loop. But this is not the topic for today. It's not a matter, but it's just a few considerations given this is very important to you because this is the basic of what we are telling you today. So what we want to ask you, and maybe Maurizio can launch this poll. So if you are using already some type of relays, we want to just ask you if you're using marshalling or coupling relays, non-SIL rated. If you're using SIL2, are you able to launch it, Maurizio?
Yeah, just a second.
If you're using SIL2 or SIL3 relays, or if you're using SIL2 or SIL3 smart relay with line and load monitoring, if it maybe is also a part of it today. Any trouble?
Yep, because I have to relaunch again the...
Okay, great. So now you can answer to this question. Maybe you can know what type of attendance we have today. So in the market, there are a lot of solutions, and there are also PLCs that are offering, of course, high current voltage out on the DO, able to covering a part of the loads. But a lot of times we see that this is not required. Maybe there are some lacks and so on. So a relay is necessary. Of course, if you can use just a marshalling relay non-SIL rate is a solution, but in case of safety PLC, you have to refer to safety relays. Okay, so we have people that are answering, so maybe we're gonna stop in 1-2 seconds. Yeah, Maurizio, sorry.
I stop?
I always call you Massimo, but you are Maurizio today. Yeah, we can share this result. So we see that most of you that are, let's say, offering and using marshalling relays and non-SIL rated, a part of use safety relays, and only few of you smart relay with the line and load monitoring. Okay, thank you for answering. We can stop sharing, Maurizio. We can go ahead with the next slides. So, safety relay for any critical application. when you use a relay that must be used in a SIF, in the safety instrumenting function, must conform and adhere to IC 61508. That is very important for and the relevant industry standards. So the manufacturer has this kind of certification, while the system integration company has to follow the 61511. Typical cases when you use a safety relay is when, as I say, when the controller cannot meet the power requirement. Okay, this is a point. So you need more than classic 500 milliamps, or maybe you need more than 24 volts. Okay, this is typical contact out parameters. Or you need the multiplication of contacts. Okay, so sometimes you need to activate more load with the same output, or you want to invert the safety function, when it's closed, when it's open, and the other way around. So there are multiple necessities, and we see that these necessities are required in different markets, not only oil and gas and petrochemical, but there are demand for having this kind of solution for railways, current lift, power distribution. But in any case where there is this is not intrinsically safe application. We are really expert, the GMI is expert on intrinsically safe, but this is functional safety. So functional safety is when there is a demand, and this demand has to be, let's say, achieved with a very, very high probability, and this probability has to be proved. So there are a lot of applications in the market where you need, it's not hazard usare, it's only safety, not only, but it's safety. So it's functional safety, and a relay or the device has to be really achieve, as I say, the safety function, the very high probability. So, and this is a typical application. So you have the PLC output, and you have your load. There are cases, of course, that the PLC output can drive directly the load. That is a perfect thing. We don't want to sell the relay when it's not necessary, because you just add another hardware to your circuit. But there are cases, of course, where, say, is needed. So you need for solenoid valves, for ESD or fire and gas systems, so emergency shutdown. That is a typical application. Fire and gas is very important. When you have to drive some beacons or some lights or whatever is as a signaling devices. When you have a burner management system, BMS, or you have AC or DC and motors in general. That is most applications. So SIF certified device. We say that standard relay cannot be used as SIF in a SIF. Okay, you cannot use in a SIF because you don't have that meta calculation for the relay or for the device that can be included into the SIF. That's why you cannot use a standard relay. Standard relay in the market are plenty of manufacturers, but we are not doing that. We are doing just the safety relays. So safety relay is a relay that we know a warranty ability to perform a given safety function. Okay, safety function is able to reach a specific safe state on demand. So it's very simple application: open or close, start or stop. Those are the main application. So safe state on demand. Safe state on demand can be open or can be closed. So there are multiple applications. We have seen some. Most of the time, of course, are in ESD. Is the load is normally energized. You have just to de-energize the load. Okay, so your PLC is open the contact, and my relay, or the relay you are using, is open the circuit. Okay, so de-energize to safety. But in fire gas or let's say other application, of course, the load is normally de-energized, and you need to energize for safety. So we divide the application for safety function. We divide in energize to safety and de-energize to safety. That is typical, as we say, application. So you have 4 different conditions how the relay coil act and so on. But on this slide, we wanna highlight this part, of course, which is very, say, significant, because you see that here I have one contact. This is my PLC typical, and the output, there are two circuit out. Okay, so this is normally energized. This is normally de-energized. What does it mean? It means that this output is active, so this circuit is closed when my system is activated. Okay, this is normally energized, while this one is deactivated. Okay, so in this case, I wanna let's say open the quota in case of demand. Can be a fault, it can be any application, but there is a demand. And see that I have 3 relays in series that typically give you the very safety to the function. So because just one relay is needed to be open in case of failure, in case of demand. So if you open one and the other are not opening for any reason, my circuit will be open, so I'm able to reach the safety application. In this, of course, normally the energized load, all the relays are not in series but in parallel. So just one relay has to be, say, as needed to be closed in case of demand. So there are typical, let's say, 2 different concepts if you want to open demand or close on demand. Let me show this part is very much more clear, basically. So I have my coil, so from the PLC, which is normally energized, and my load is normally energized, typical application. So when there is a demand, let me go ahead. The safe states means that I'm able to open, so de-energize my coil, and my relay will open the circuit. That is another application. The other one can be this one. So I have always a normally energized coil, but my load is, you see here, is open. So the safe state on demand is that I de-energize my coil and my contact will be closed. So I'm able to turn on, in this case, this light, beacon, whatever it is. Okay. So I can have also the solution where I have normally de-energized and my relay is closed. Safe state on demand in this one. So close the energize my coil and open the contact. So the energization of the valve. And the last one, of course, is the other way around. So the energized coil, normally open contact. I wanna, of course, in case of demand, close this circuit. Those are the typical applications we are covering with in GMI. We have all these solutions, different relays, of course. You can have also one relay that is covering a lot of probably all this functionality. But we want to just only talk about the technology and what is the importance of using a safety relay. So for non-energized application, basically I have a circuit like this, and one relay is sufficient for non-energized for reaching the SIL 2 certification. Okay. If I'm using 2 relays in series, okay, this is sufficient for SIL 3. Okay, normally energized. But there are the cases for normally de-energized application where one relay is only able for reaching SIL 1, while 2 relays for SIL 2, and you can imagine 3 relays are for SIL 3. So there are typical different configurations that grant different cell level on your safety relays. But in GMI also we have talked and we take care about the availability. So the safety is not going on the same level as availability. Okay, they are not working on the same say trail. They are sometimes there is opposite behavior or opposite say I'm increasing the safety, maybe I'm decreasing the availability. Okay. I see here that I have an application normally energized and my relay are closed, okay, and I'm working safely, okay. Basically, what happens that I have very high safety, but a low availability because I don't need. In this case, I didn't ask for opening. Didn't have a demand for opening the circuit. I don't have any problem on my circuitry. So I see that my relay is opening accidentally. So I see that from my point of view, I'm SIL3. If you remember, this was SIL3, but the availability is low because if one relay got a problem, my circuit will open. So I have high safety, but very low availability. Okay. Also, in this case, for normally de-energized, if you remember, this was circuitry for SIL3 applications, but I can have this situation. I'm not asking for closing, but one relay, one contact stuck, and I'm completely losing my availability. So safety and availability are two concepts that, of course, in the IC 61508, 511 for users, of course, this is not the availability is not a requirement. The requirement is safety, only safety. So but from the user point of view, this is a big challenge because maybe they're gonna stack a problem, they're gonna stop the plant for whatever reason, and without having a real demand, real safety need. Okay, so this is a big problem. So I want to also discuss with you about this circuit for normally energized load. I have 4 circuit, okay? So 101, 1 out of 1, 1 out of 2, 2 out of 2, 2 out of 3. So I have a different application. I have 1 out of 1. I see that, let's look at the table. So probability safety failure per year is 25 years, okay? Dangerous failure is 50 years, okay? Because this is the very important part, okay? This is a safety failure. It means that maybe is losing availability, or dangerous failure. When I'm try to close a circuit, in this case, open circuit, but my relay stuck, I cannot open. So I'm say having a dangerous failure because I have a demand for safety, but I'm not able to open circuit. So this is considered dangerous. Okay, 1 out of 1. If I'm using this circuitry, 1 out of 2, which is 2 relays instead of SIL3, so you see that the probability of a safe failure is higher because I have 2 relays that can open without, you remember the previous circuit, I can have 1 relay that can open without demand. So my probability of safe failure is of course lower. So, higher probability for safe failure. Okay, so this is the match. But in this case, that the dangerous failure are definitely better, 50 times better if you check here. Why? Because it is, I mean that I have 2 relays that on demand have to open. So just one has to close in case of demand, or open in case of demand. So this is definitely, one can stack 2 that can stack at the same time is very, very unlikely. So I have also this circuit that is not good for this normally energized, absolutely, but it's just for giving, say, to you more details. So I can have a probability of safe failure that is, say, better, of course, definitely better, but the dangerous failure drastically go lower. So this is not a very good circuit for this kind of application. Okay. I can have this application where it is 2 out of 3, so 3 relays voting. So, and the voting system give you of course, very good parameters for safety failure and very good also for dangerous failure. So you see how the schematics can change a lot the probability for safe or dangerous failure in the circuit. Hope it was good for you. This part, it was a little bit complicated, especially the last part, but I think you can have much more details. Can we launch, Maurizio, this new poll?
Yeah, just a second.
So what feature for safety relays is the most relevant for you? Of course, we have seen that CL3, very important or not. High availability, very important. Only one suitable for non-energetic and non-energetic application. You are looking for a relay that is, you want to have just one for ND and E applications, or you prefer also maybe have multiple contacts? So which one is the? Of course, maybe you have more preference, but just highlight the one that you are looking for.
There are a lot of different
All are good. All are good, I see. All are good, but we see that the availability is quite interesting for people. Yeah.
Yeah, first one, yeah. Most of the case, high availability.
Yeah, we see for availability that there is, especially end user are looking for high availability, looking for this capability. Of course, they need to be safe, but they need also availability. Okay, we can stop, Maurizio, if you want to share this poll.
Here we are.
Okay, we see that the winner is availability. Good to know. Okay, thank you. We can go ahead with the next one. Shop sharing, perfect. So in GMI, we develop this kind of circuitry. You see that we have a matrix of relays. Two relays are in parallel. Here, two other two in parallel, and those are in series with the loads. Okay, so in case of you see, remember the problem for we had before. So one relay is stacking. So, but if the other are opening, my circuit is of course open here. So I'm able to reach a safe state on demand, even if one relay is stacking. And also for normally energized application, can have a situation where I want to close, but this is not closing. This is not a problem, but the circuit is granted closed by this part. So one safety fail on one relay fault is not sufficient for dangerous failure. So we call hardware fault tolerance equal to 1. So this is for safety, but we said it's very good for availability. So availability means that I'm not asking any movement on safety for opening the circuit, but one relay is opening, but not losing the power here. And so I'm not losing the availability. And also for normally de-energized, one is stuck, I'm not losing any availability because the circuit remain closed. So this kind of circuit is very good for safety and availability. So the other topic we have, we want to, of course, discuss, of course, is the diagnostic. We see that there is a really high demand for smart relays, safety relays with the line monitoring. Of course, you have most of the DO cards for safety PLC offer already the line monitoring. But if you use a relay, because you need a relay, because you're not able to drive that kind of load, that relay basically is an isolator. So the pass testing from the DO card will be, say, drastically stop into the relay coil. Okay, so this is a limitation for the diagnostic. Okay. So you need a relay because you need more power, but at the end, you are not able to monitoring the loads. Okay. So the PLC diagnostic can reach only the coil side of the relay and not the field that was the main purpose. But in general, we developed some smart relays that are able to have some built-in capability, able to, of course, cover this functionality. This is not the discussion for this webinar, but the smart relay are able to give you the details about any short open circuit or power supply you got on the load side, and reflecting these values or this fault to the PLC. Because this the past testing, of course, is good from the PLC, but if you're using this relay, of course, the relay is isolator or 100% isolator, so you cannot use that. So the conclusion for this webinar, then we have another small session for some demand that are questions that we got from you during the session, during the registration. So conclusion is improve safety diagnostic levels. Indication safety lanes shall maintain the safety loop requirements in 2 and 3 along with the safety diagnostic if present. So you granted this for safety PLCs like Tricon, like EMA, like and others that are also Siemens, that this relay is able to grant this safety until the load. High availability and fault tolerance, so prevention of spurious trip and high availability besides safety are key factors in the process control. That we have seen that this, especially these matrix relays we're using most of our solutions, are offering safety and availability. Certified design, SIF certification. All-in-one solution, you can use one relay for multiple solutions, okay, yes, different gas. Past testing compatibility, so there are relays in the market that are not compatible with the past testing. So past testing from the OCR sometimes cannot be excluded, and if the relay you are using is not compatible, is not able to filter the past testing, the relay out, the coil will be activated, the relay out will flicker a lot. So maybe you can, if you are flickering, the electromechanical relay is going to damage in a few, let's say, 1,000 or maybe 100,000 cycles, and this is a big problem to you. So our relays are not like that. So closing, let me stop sharing this part and go to the other. If you have any questions, I don't see any question from you. Maurizio, no question from the people?
Seems no. I'm just checking, but no.
Hope you are still there. Pay attention and that you need to stay at least 75% of forgetting the certificate and from us. This is very important. Okay, so I have this part. No, it's not this one. Sorry for. Oh, yeah, this one. Maurizio, can you confirm you see the new slides?
Yeah, I confirm. My webinar. Yeah.
So, safety relay installation as Ardusare. This is, we have a Q&A session. Oh, those relays, this is a typical circuit for some standard relays for, you see, is for normally energized contact, basically. Of course, there are 2 contacts that can be used. Of course, is a possibility. You have also service out load non-seal that is used for detecting loads fault. And this is for installation in zone 2. So there are applications where maybe you're gonna apply in the zone 2 area. Let's remind you that the relays are not for hazardous area, can be used, of course, in zone 2, but are not not intended for zone 0 and zone 1. In that case, you have to use barriers but the barriers, of course, offer limited power to the loads. Fast testing compatibility, what is this? Yeah, we have slides, maybe give you more details. I just mentioned to you this part. And the fast testing, of course, is you have the two applications for normally energized. Use that pointer. So for normally energized or normally de-energized. So the fast testing is this one. So you have up, down, up, down. So you have for only a few milliseconds, you have this kind of cycle. And is intended to be used when you connect this DO card directly to the load. Okay, if you have the application, I remember that supports the limits of the DO card. But when you use a relays, this is, of course, it cannot be transferred to the load because there is a full isolation, and this is very important. Also to preserve the DO card. And but this fast testing, if it cannot be excluded here in the PLCs, can damage the coil, can damage the relay, can activate it continuously the output. May happen. So our relays have this circuit is a filter that is able to filter this fast testing without this, say, length of the path is not able to activate the load. So they prevent the contact shattering, spurious load activation, premature damage of the relay unit. Okay, so is there any solution offering multiple contact output? Yes, we have one relay, or more relays, but this is just an example where you have can be used for 2 normally energized relay with the CL3, or 4 normally energized with the SIF2, or 2 normally energized with the CL3. There are multiple applications for this relay. So you can use multiple contact out. We have also one solution for unipolar or bipolar. Okay, this is a very important. This is a question because we see that the bipolar or unipolar wiring, when you have a load which is far away, maybe is very common, is useful to connect the load with just one wire and go through the ground to the system. So this is a unipolar wiring. Okay, we have a solution, and it can be used, of course, let's say that the 2 wire give you a complete isolation to the system. This is important. And it has to be used in case of high voltage load. If you have a low voltage load and you have a load far away from the system, you can connect in this way to the system. I want to also highlight one part, which is that the line monitoring. We have one solution that for this line monitoring is a standard. Of course, we can offer relays with the line monitoring, but there are line monitoring available also. One relay is able to monitor the load also when you use this kind of connection. So the unipolar wiring. Let's see for the next question. How choosing relays? This is so you need to check first if you have in general, if the relay is compatible with fast testing. If you have, of course, the fast testing case, what kind of PLC coil voltage you have? You can have 24 volt, 110, 230. So there are multiple solutions. Okay. If you want, of course, the load type, if it's normally energized or normally de-energized, this is another point. If you want to have a single multiple contact via the same output, the PLC output, you want to connect to single or multiple loads. What is the current rating? 5 amps, 10 amps. And if you need line and load diagnostic, so if you need to monitoring open short circuit, which is the most common, if you need a low supply, earth leakage, it is also a demand. So this parameter has to be considered when you use and safety relays. So you see here, coil can be 24 volt, 48, 110, so multiple. Relay contact can be 3, 5, 10 amps. You can have a single contact open, single contact output, multiple contact open, multiple contact out. Another point is we haven't discussed too much about that, but the fault mirroring. So when I have, this is the system DO card. You see the path testing generated by the card. As we say, this is a died completely at a relay coil. No way to extend to the load. That's why we developed this, especially this relay, but is one solution. And is able, this relay, in case of fault, I see open circuit here. I have open circuit. I'm able to transfer this fault to the system DO. How? Basically, this fault is reverting high impedance value to the DO, to the DO out here, DO in here. Sorry, the out from this, the PLC and the from the system. So the system DO will see that there is a different impedance and will detect this fault. We call it mirroring. So in this case, when you use a safety relay with a line monitor, you don't need a any special or any additional digital input for achieving or for, let's say, detecting the fault. The system they always see this part. Very important, because if you have a lot of relays, you would need extra DI card on your PLC that needs more, let's say, wiring and so on. Okay, so if you have any question during, otherwise I will go through that. Can the fault for a monitor relay be interfaced with the field bus? Oh yeah, we have also a solution. This is an application, and this relay is able, 5294, is able to perform this. So in case of fault, I can have, so I have a, see here a coil on the coil of the loads is having problem. Or I can do retransmit over two multiple. I can have also as well the mirroring, but I have the digital input fault. I can have the Modbus solution. But the Modbus is also a useful way how to connect the relay to the system. So a Modbus port can get multiple relays or multiple Modbus registers, so you can detect, and say also the advantage of having that is you can detect the type of fault, while the mirroring gives you just information about the fault, you don't know what is that. Here the Modbus can give you more details, and the fault is detected by the real reasons. Oh, other question was SIL3 relay can be used in SIL2 application. Okay. This is a typical circuit. So the SIL level can be 1, 2, 3, and 4, because the 3 is the most, and the 4 is not used in this in the process application, mostly using maybe a railway application. But in the process, let's say let's focus on SIL3. I say that the SIL3 relay, of course, if you see that the SIL3 is much more bad than SIL2, the probability of failure on demand is lower than a SIL2 values. Of course, SIL3 relay can be used in the SIL2 application, but not the other way around. So if you need SIL3, you have to use SIL3. You cannot use SIL2. If you need SIL2, you can also use a SIL3. Okay. if you use a system, or say a relay, but any device that is CL3, this CL3 is allowed to reduce the frequency of T-proof, testing proof. So a device, if it is a CL3, it can be CL3 for a few years, okay? It cannot be forever CL3. It has to be tested, okay, gradually, after a certain interval of time. And of course, if you use, for example, a CL3 device, then maybe it's CL3 for 1 year. After 1 year, see that 1 year it degrades. See, you move from CL3 to CL2. After 1 year, you have to test it to restore the condition as new condition, okay, to get the device in CL1 level, okay. So you need this testing, okay. But I would say that if you have CL3 that is valid for 1 year, you can have a CL2 that is valid for 10 years. So the same device can be used for in the CO2 application, and the T-proof time can be extended dramatically. So you can, of course, take advantage of using CL3 in a CO2 applications. Safety relay design aspect. Why is important to use, and why is seal the device seal? Okay, so the base of seal or to increase seal level is to use architectures. Okay, so the architecture give me, say, increase my safety. Okay, safety level. So if you remember, you have maybe for non-energized, you need 3 relays in parallel for reaching the CL3. So the architecture give you, say, increase the safety level. In the same way, architecture are using the SIF. They are also used in design of SIF-related components. So a relay, battery, so on. So also inside, of course, there are components that are using special architecture to increase the safety level. It's important to know that there is also a beta factor. I'm pretty sure that some of you knows about this beta factor. So if you have the same component, if you use the same device, same transmitter in the field, made by the same manufacturer, in the same batch, same device, same batch, same manufacturer, this will be a risk, increase your risk, because the devices can fail probably at the same time. Not sure, but can fail at the same time, or maybe after more or less the same period of time. Okay, so very important, the beta factor. So architecture can affect safety and availability in different ways. If you use 2 transmitters, 3 transmitters for reading the same values, same let's say values can be, I don't know, temperature or humidity or flow, whatever. But if you use 3 different technology or 3 different manufacturers, this reduce the vector factor, reduce to 0 the vector factor. There is no common fault on the, of course, on the reading of the measure. There are, of course, basic component failure rates. So the SSF table also apply to better component design, better components, better results. So in the standard relay, these are not taken care. So relays and components, of course, are given by the manufacturer with a certain PFD that are calculated that give all the PFD of the device you are using. Characteristic of the component increase or decrease the resulting seal data. So gold plating relays, cilium relay, force contact, single multiple internal contact. So there are multiple factors for reaching the safety in the components. Of course, determine the seal level of the component several parameters are to be evaluated in the FMED analysis. So all parameters of the single components are calculated and give the FMED analysis of the relay that you are using in the device. So we use high rated components. So they not component that stand only 50, but components stand at 70 degrees. Okay, 70 degrees in environment that inside can be 80, 85, 90 degrees. So this is also a value, important things to increase the availability, increase the lifetime of the device. Because if you're using component is 50 degrees, certificate for 50 degrees, are using always at 50, let's say, not exceeding. But you're going, as in your car, if you're going always at the maximum speed, you cannot, the car cannot last forever. So the importance of having high rated components in the relays very important in any device. So, and of course, there are safe failure, dangerous failure, important consideration. MTBF safe and dangerous must be evaluated. So, and of course, the dangerous failure are the most critical, because if you fail, your device fail in a safe manner, is of course, it's not good, but it's not bad, because you are not you're failing, but you're failing safe. But if you are failing and you are dangerous, maybe that means that maybe you are not say reaching the safe state when there is demand. That is are all critical aspects you have to take in account. Okay, safe failure and dangerous failure. There is also this, did not forget it. Last point, then we close, I guess, because otherwise I still see people there, so maybe hope they are awake. We have so the failures can be safe and dangerous. Of course, the safe are safe detected and safe undetected. The dangerous are the danger detected and danger undetected. So the total failure is a safe detected, safe undetected, plus danger detected and danger undetected. Of course, this is the most all, but the one that are critical are dangerous undetected. Because I can be dangerous, but if I can detect, I can prevent, I can do something. Okay. The most important or the critical part when it's dangerous is undetected. So maybe my plant got lost, I can have fire, I can have problems, and so on. So, and this is the part. So the 4-20 is, of course, an example. Of course, if I have a 4-20 milliamp signal and my signal go below 4 or up 20, more than 20, I see that I can have danger detected, because it's dangerous, but I see that my value is more than 20 or lower than 4. And it can be also safe, but it's also detected because it's over the limit. The most critical part is in the middle, because I can have, of course, a small variation is undetected, but is safe, because that does not, let's say, perform or does not affect too much my system. But am I having a big difference? Maybe I think that my value is maybe 6 milliamps, but basically, maybe is not true, because my temperature is going up. I don't know, is 18, 19 milliamps that correspond to, I don't know, 600 degrees, but I don't know, because I see these 60 degrees. I don't know. It's just an example, but just to give you this, if my value is in the range of 4-20, it can be dangerous and can be absolutely undetected, because I don't see any trouble. This is not an example. So danger undetected are the most very critical part. Gold plate contact, very important, because I give you, let's say, you can use for leader current. Leader current can let's say, cause oxidation on my contacts, and I can damage the contacts. So the gold plated are very important, because maybe you have 5 amps, but in some cases you can also drive low currents, and if you are not using gold plate contact, you are having this kind of solution. Well, it's still long. I see here that diagnostic coil relay classification. So I see that the diagnostic part, very important. I see that my circuit, safety circuit is CL3, but the diagnostic is CL2, non-interfering. So that's why is important to know. This is the last one. Sorry for that, but we need to close it. And process machine safety. We have talked about process, not machine. Machine is not a word. We have no solution. Machine safety, of course, the required non-seal is a PL, protection level. Can be used for safety gates, light bearing, light grids, speed stands. Manual control is possible. While in the process control is everything is under control of the PLC. Okay, so two different words. Okay, because sorry for that, we exceeded 1 hour, but remember that here we have, you can see on our live webinar schedule on Gemini. You can, of course, be updated over LinkedIn. Thank you for rating. If you want to just take a few seconds, Maurizio, if you want to launch this poll, how was it? We don't share it. We hope that it was good for you. It's very important to have your, of course, feedback because we want to just improve in our communication. Okay, thank you for answering.
Thank you.
Okay. People are still there, perfect, and answering, good. Good sign from you. Okay, we can stop. Thank you, Maurizio.
Okay.
And we want to just remind you that, of course, if you need more details, if you need more support, this is our contacts. Thank you again, Maurizio. Thank you all our attendees.
Thank you, Andrea. Grazie mille. Thank you for attending. Thank you.
Thank you. Bye-bye.